Hey guys, welcome back to week 2 of probability. Uh, Last week, y'all worked on simple probability and simple events. And this week, we're going to start off with theoretical versus experimental probability. They look like big words, but they're not as scary as they seem. Below, we have the definitions, and I'm going to explain what they are. Theoretical is probability based off of reasoning or what should happen. It's what we've been talking about in classes, which is what you've already been doing online. For an example, theoretically, if you flip a coin in the air, you have a 50% chance it could land on heads or a 50% chance it could land on tails. That's in theory. Nothing actually happened. It's just kind of what we would expect to happen. Now, experimental probability is probability based off of an actual experiment or an event that has already happened. So what did happen? So hypothetically, theoretically, if I were to flip a coin in the air twice, you would think, or the odds would be that one out of the two times it would land on heads, and the other one out of two times it would land on tails. But we all know that if we actually did that, experimentally, it could be different. If I actually did it, it could land twice on heads in a row, or it could land on tails twice in a row. On the next couple pages, we're going to do some examples. A little precursor. This week's assignment, the IXL only goes over experimental probability, but the assessment or the assessment after experimental probability IXL has theoretical and experimental, so you do need to know both. Okay, so here's some examples. I'm going to go over theoretical first and then experimental. So theoretical, talking about flipping a coin here. Now remember, I put this little star down here as just kind of don't forget that whenever we do probability, our top number always represents the number of ways that our option can occur, and the bottom number always represents all the total possible outcomes. So flipping a coin. First question says probability of landing on tails. So what I know is that when I flip a coin, I have a total number of possible outcomes that is 2. It can land on heads or it can land on tails. Now, what's the probability of landing on tails? The number of ways tails can occur. How many ways can we get tails? Well, only one time. There's only one tails on the coin. Second question is very similar, but it's the probability of heads. Bottom number is the total number of possible outcomes. Well, there's 2. It could land on heads or tails, but only one of them is heads. So once again, both of them are 1/2. The probability of landing on tails and or heads are both 1/2. Now I'm going to flip the question a little bit. Now I'm transitioning over to experimental probability. Experimental probability talks about an experiment, something that did happen already. So here is our experiment. Jenny flipped a coin 10 times. She landed on tails 6 times. So what is my probability of landing on tails based off of the experiment? What's already happened? So my first question is, how many times did the coin flip? It tells us Jenny flipped a coin 10 times. So now my bottom number is 10 because that's what took place in the experiment. And it says she landed on tails 6 times. So the number of ways that were what happened, she landed on tails 6 out of 10 times. This is a correct answer, but it's not simplified. We always want to simplify it. This simplifies down to 3/5. So now the second question is, what's the probability of landing on heads based off of the experiment? Well, if she flipped a total of 10 times, and we know she landed on tails 6 of the times, the remaining number has to be the number of times she landed on heads. So that's a 4. So our top number is going to be 4, and she performed the experiment 10 times. Once again, this can simplify to 2/5. Okay, we'll move on to another example, and then you guys are going to try some on your own. Now we're going to refer to the spinner. Theoretical on the left side, we're going to start there first. So theoretically, not based on any experiment, just looking at the spinner, what is the probability that she lands on green or red, green or red. So I need to calculate how many total possible outcomes are there first. Well, looking at the spinner, I see 4 equal sections. So there are a total of 4 different possible outcomes. And how many of them are green or red? That's what's going to go on top. I see 1 green and 1 red for a total of 2 possible outcomes. 2/4 simplifies to 1/2. Number 2, still on theoretical probability, says what is the probability of not blue? Not blue. Still, there are 4 equal possible outcomes total. And how many of them are not blue? I count 3 that are not blue. The answer is 3/4. Now, same spinner, but we're going to go with experimental probability. And notice we have an actual experiment that happened. Sean recorded his results of spinning the spinner in the table below. That is talking about this spinner. So here are our results, or not spinner, that table. Here's our results. I really don't even need to look at this spinner, but it's there anyways. But what I'm really looking at is the results of what happened. So number 1 says, what is the probability of green or red? Okay. So what I need to do first, or I'm going to find out how many total possible things were, or how many times did the experiment take place. I need a total. My total is no longer 4. My total is going to be how many times was the experiment done. By doing that, I know he landed on blue 5 times, green 3 times, red 4 times, black 8 times. So I'm going to take all these numbers, 5, 3, 4, and 8, and I'm going to add them up to find out how many times was the experiment even done. And I get an answer of 20. So since the experiment was performed 20 times, my bottom number is going to be 20, because that's how many times the spinner was spun. And how many of them were green or red? So I'm going to calculate my green and red together. I had 3 green and 4 red for a total of 7, and that is my top number, 7/20. 7 out of 20 times he grabbed green or red, and that is my final answer because I cannot simplify. Number 2 says not blue. So I already know my bottom number is 20 because that's how many times the experiment was performed, and how many were not blue. So I'm going to calculate all that's not blue. So I have 3 green plus 4 red plus 8 black, and I get 15. I think it was 15. 15 out of 20, and it is 15 times it was not blue out of 20, and I can simplify this all the way down to 3/4. Okay. On the next page, y'all are going to try some on your own. On the left is theoretical examples. On the right is experimental probability based on an experiment. So go ahead and pause the video and get started. All right, hopefully you pause the video and you attempted some of these on your own. So let's go ahead and do number 1 on the theoretical side, rolling a fair number cube. What is that's a dice. What is the probability of landing on a 5? Well, when I roll a die, there are 6 total possible outcomes. And how many 5s are there? There's only 1. Number 2, a 1 or a 4. The total number of possible outcomes does not change. It's still 6. And how many of those numbers are a 1 or a 4? On a dice, there's 1 1 and 1 4 for a total of 2. So I get 2 6, but I can simplify this down to 1/3. And that is the answer for number 2. Number 3 says the probability of not a 1 or a 2. Okay, so now this is not a 1 or a 2. So my total number of possible outcomes when I roll a die is still 6. How many of them are not a 1 or a 2? So let's list out all the possibilities. I can get a 1, a 2, a 3, a 4, a 5, and a 6. So how many of them are not a 1 or a 2? 2's not a 1, or so well, no, 2's a 2. Can't do that. 3's not a 1 or a 2, 4's not a 1 or a 2, 5's not a 1 or a 2, and 6 is not a 1 or a 2. So 4 of those. So 4 out of 6, which simplifies to 2/3. 2/3 is my answer. That is theoretical, what should happen. Experimental, based on an experiment. We have another table here. So Ashley rolled a fair number cube 10 times. The table below shows the results. So I don't care about what a dice should or should not land on anymore. All I'm concerned with is this table over here. And luckily, this question, I don't even need to calculate the total because the question already told me she rolled it 10 times. So what's the probability of landing on a 5? Number one, I know my bottom number, 10, because that's how many times the experiment was done. And how many of them were 5? Well, I go to my table. The number 5 was rolled 1 time. The probability there is a 1 out of 10. Number 2 says a 1 or a 4. Once again, I already know how many times the experiment was done. It says she rolled it 10 times, so that's my bottom number. And how many were a 1 or a 4? So a 1, I see a number 1 was rolled 3 times, and a 4 was rolled 2 times. That gives a total of 5. So that's my top number, 5 out of 10, which simplifies to 1/2. And number 3, probability, once again, of not a 1 or a 2. I know my bottom number is going to be a 10 because that's how many times the experiment was done. And so just like we did look at number 3, I know that not a 1 or a 2 means 3, 4, 5, and 6. So a 3 was rolled 0 times. A 4 was rolled 2 times. A 5 was rolled 1 time. And a 6 was rolled 3 times for a total of 6 times. So my top number is 6. 6 times not a 1 or a 2 was rolled. 6 out of 10 simplifies to 3/5. I hope this adequately explained the difference between theoretical and experimental. If you guys have any problems, please make sure to attend tutorials. Good luck. And once again, remember that the IXL assignment is only experimental, but the assessment after that is experimental and theoretical. So please take your time. Good luck.